All right, this is your day 37 assignment, and it is on momentum. And it's one of two short videos I'll ask you to watch for this particular assignment. So what is momentum first of all, and what is the formula for momentum? So momentum equals an object's mass times its velocity. Remember, force was mass times acceleration. It's how fast the velocity is changing. That's acceleration times the mass. But this is just mass times velocity. The abbreviation for momentum is a small p, because it probably ran out of other letters. M is used for other things. So we write the formula for momentum as P equals mvi, mass times instantaneous velocity. Some books write the formula as P equals mv, but you need to use instantaneous velocity, vi, not average velocity of v. Okay, so compare momentum to force. So when an asteroid is traveling through space at a constant velocity, it has momentum but no force because there's no acceleration. It's mass times velocity, that's momentum. But if the velocity is constant, it doesn't matter how fast it's going. If the velocity is constant, then there's no acceleration. Therefore, it has no force. So when does it have force? You know that big heavy object moving at a high speed, if it hits something, then it's going to really make an impact. Well, that's when it has force. So once the asteroid strikes a planet, the sudden negative acceleration going from, say, 10,000 miles an hour down to zero really fast, that's a negative acceleration. It's slowing down really fast. That's when it has force. So it can only have force by hitting something, not just by flying through space. All right, pulse, which is also called impulse. A pulse is a force times the amount of time it is applied. So pulse equals force times time. And the units of measure for pulse are the same as momentum. And so for both of these things, both momentum and pulse, is kilograms, because that's mass, times meters per second, because that's velocity. So mass times velocity. And it's kilogram meters per second. Pulse is also called impulse. And I think of pulse as the amount of force times the amount of time it will take to remove the momentum from an object. In other words, to make it come to a stop. That's the pulse. So you can either use a high amount of force and a low amount of time, or a low amount of force and a high amount of time. Let's see an example on the next slide. Okay, so here's how you relate impulse and momentum. Let's say a soccer player shoots a soccer ball at the goal with 15 kilogram meters per second of momentum. So the ball has 15 kilogram meters per second of momentum moving toward the goal. There's two ways the goalie can stop the ball. In case number one, the goalie can punch the ball away. Sometimes goalies do that just to get the ball out of the goal area. And they can do that by using a lot of force for a short amount of time. Think of what a punch is. You make a fist and you hit something really hard, but your fist stays in contact with the object for only a very short amount of time. So in this case, the 15 kilogram meters per second could be a high amount of force, 150 newtons, times a very short amount of time, 1/10 of a second. Those are the numbers in green. So high force, short amount of time. That's if you wanted to punch something away. You wanted to just stop it, hit it really hard, and make it go away. Now, case number two, the goalie can catch the ball by letting the ball hit his body softly. So he does this by using a small amount of force spread out over a longer time. So if you see the image at the bottom, you see it's still 15 kilogram meters per second of momentum that the ball has. But in order to bring that to a stop, you can use a smaller amount of force, 15 newtons instead of 150, but you spread that out over a longer time, 1 second. So 1 second is 10 times as long as 1/10 of a second. So by doing that small amount of force so that the ball won't bounce away over a longer period of time, you can also remove that 15 kilograms of momentum from the ball. So that's our short lesson on momentum. There's a second video, and I'd like you to watch that. And go ahead and fill out the short assignment, and we'll see you tomorrow.